A runner runs 12 kilometers per hour for the first 1.5 hours of a race, and then speeds up to a speed of 20 kilometers an hour for the last half hour. Pretty good. Part A. Calculate the distance that the runner has traveled after 30 minutes, an hour and a half, and 2 hours. Part B. We're going to draw a graph comparing the time and the distance that the runners run over the course of those 2 hours. And C. What is the reason for the difference in the gradients? Well, this is a hint that there's probably going to be some different gradients going on here. Let's hope that's the case. So part A, calculating the distance that the runner has run or has traveled after, start with 30 minutes. Well, first of all, 30 minutes is half an hour. So they are traveling for half an hour at 12 kilometers per hour. So the calculation we do is 12 kilometers an hour times 0.5 hours tells us the runner has gone 6 kilometers. I encourage you to try part I yourself. Here they're traveling 12 kilometers an hour for 1 hour, which is 12 times 1. They've gone 12 kilometers. Fancy that. Part 3, 1.5 hours. Again, give it a go yourself. 12 kilometers an hour, and this is where we have to start thinking a little bit, for the first 1.5 hours. So they're traveling that speed the entire time. 12 times 1.5, that's 18 kilometers. Probably sitting there thinking, oh geez, Mr. Templin, this is too easy. We have some sort of a challenge? Well, fear not, friends. Here we are. Part IV. How far has the runner gone after 2 hours? Now, we can't just do 12 kilometers an hour for 2 hours, because she's only going at that speed for an hour and a half. After that, she speeds up for the final half hour. So for an hour and a half, she's still going 12 kilometers per hour. But then she's going 20 kilometers an hour for half an hour for the rest of that time. So there's two pieces to this, two distinct, important parts to this run. So 12 times 1.5 for the first bit, plus she's then going 20 kilometers an hour for half an hour. That's 18 plus 10. She's gone 28 kilometers after 2 hours. Part B asks us to graph, comparing distance and time over those 2 hours. Well, what we're going to do is we're going to plot the points that we have. Our points from part A. Each of the x values, well, that's our time, which is t, and each of the y values, that's the distance. So these points here should look familiar. Oh, I've written something wrong here. That should be 28. So after no kilometers, just as she starts, she's gone 0 kilometers. After half an hour, 6, an hour, 12, and so on and so on. So we're going to plot those points. 0, 0, 0.5, 6, 1, 12, and so on and so on. And then we're going to connect those with a line. Notice that here, the line is straight. Here the line is also straight, but it changes. And that's okay. But the line changes partway through. The question is why? Well, the rate of change. Remember, the gradient here is the change, or the units for y, which is kilometers, over The change in x, which is hours, kilometers per hour, that's the speed. And the question told us the speed changes. So as the speed increases from 12 to 20, the gradient increases, because speed is the gradient of a distance-time graph.